Right folks, what we're actually going to do today is another surface development of a cylindrical section here of a bit of pipe work. It says in the question, the graphic shows a plastic pipe which incorporates two cylindrical sections, section A here and down here the piece at the bottom. From the plan and elevation provided, draw the surface development for section A of the pipe. So, if we look at the pipe, we can see obviously it is, if this was sitting flat on the ground, then section A is at an angle to the horizontal plane. Don't know what angle it is, but it's sitting up obviously at an angle to the horizontal plane. It's obviously cut at another angle here, so it's truncated on this side, and if we were to remove this section, it would also be truncated on this side. So that would generate two ellipses as well. Now, very much like another day when we completed a question like this, what we need to do is we need to get the generators that run along it. So there's going to be a series of generators that run along it that actually generate the cylindrical section before it was cut at an angle. Now to get those generators, we need to see the true shape of it when we look straight at it, either from this direction or from this direction. And the shape that we would see when we look down at when we look at the cylinder from those two directions is going to be a circle. And what we do usually with the circle is we break it up into 30, 60 degrees, and we get 12 segments, and each of those segments is going to have a separate generator. And we're going to use those generators then to help us do the surface development of this. So what I'm going to do now in a second is I'm going to pan out, going to go to the elevation of the plan, do the auxiliary, and after I do the auxiliary, we'll get the true lengths of each one of those segments, and then complete the surface development. Okay, so as we can see, we have the elevation here and we have the plan view here, and what we have to do is, as I said, we have to complete the surface development of the cylindrical section A. But before we start that, we need to get the auxiliary view of it when we look straight at it. So I could take my auxiliary, if I was looking in this direction, my auxiliary would project down here, or if I'm looking in this direction, my auxiliary would project up here. It doesn't matter which way I take it. For the sake of it now, I'm actually just going to take it up in this direction up here. Okay, so I think the way it's working out is the angle it is inclined at is at 30 degrees to the horizontal plane, which is the XY line. So we are going to project that up at 30 degrees. And set up an X1, Y1, perpendicular to my projection lines. X1, Y1. Now, we can tell straight away, we know the radius from the cylinder because we can get the radius straight from here, because obviously the center is here and the top of it is here, so it has to be the same radius, or I could take it straight from my plan. Now, I could take the distance out, and I could measure the distance from the XY line down for the center, take that and mark it off. However, it's just easier to take the radius straight from it, so I'm going to take my datum line from this edge right here, not the XY line. Makes no difference, I could do the XY line, I'm just trying to keep it neat and tidy on my page. And all that means is every measurement, if I was to take it, I would be taking it from this line right here. I'd have a datum line there. Now, at that point, I am now going to do my circle, which is what I would see when I'm looking straight at the cylinder. Nice and easy. And then what I would also have to do is, I said at this stage we're going to break it up into 12 sections. So if my lines were projected at 30, going up the middle the other way is going to be 60. Okay, I'm going to label. I'm going to start with this one as number 1. This will be, I'll have missed 2, 3, this will be 4, 5, 6, 7, 8, 9, 10. Nice and easy. And now I'm just going to break it up. So I'm going to use my 45 degree set square for this. Sliding set squares. So 30 degrees in this direction, 30 degrees in this direction, always through the middle, then 60 degrees, and then last time around 60 degrees only going this way. Label the rest of my points. So I've had 1 here, now I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 12 will obviously go back to 1 to finish off the segment. Or the cylinder, sorry. Okay, so now at this point, guys, what we're going to do is all of these sections that we broke up into 12 sections here, like a clock face, 1, 2, all the way to around to 12 and back to 1. Every one of these, if we were to look down it in this direction, that would be a generator running along the face here, so it would. So at 1, that's actually a generator there. At 2 and 12, there'd be a generator running down here. At 3 and 11, 4 and 10, the generator is already there running along it. And all those generators are actually going to be true lengths as well. So what we want to do is we just want to represent those, because we want to see where the intersection points are, where it cuts the face here and here. So we projected up at 30 degrees, so we're going to project back at 30 degrees. So 6 and 8, it's going to be there. 9 and 5, 4 and 10 are already there. 11 and 3. And then we have 2 and 12. And once again, just labels. Now, there we go. Labels nice and easy. Now what we have to do is we have to project up perpendicular to this with all my points to start the surface development. So, I'm going to start with number 1. I've got 2 points for 1 because I have 1 here and up here. I'm going to use that as my guide. Start with 1 because it's the shortest one, and then we'll finish obviously with the longest one is 7. So that went up at 60 degrees, this point here. Okay, I can heavy in that edge because that's going to be my number 1. That's my starting point. And I'll just label it again, 1 and 1. Now, at this point, what we're going to do is we're going to use our true lengths from here, from one of our segments. So I'm going to take the distance from 1 to 2, because we cannot obviously measure a circumference with a ruler. So what we do is we take the distance of one of the segments because they're the same the whole way along. 2 to 3, same as 3 to 4. And we're going to mark it off 12 times until we get back to 1. So I always count at this point. So I'll be like 2. So if that's 1, 2, 3, and back to 1. Very simple. Once again, important to label. So I got up here at the very, very top. This is where it will finish. Because 1 will come back around to 1. So there's my 1 and 1. And for the sake of it now, I'll just go, sorry, that would actually be 12. So I'll go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we obviously had 12. And after that then, every one of these lines is a generator. Imagine it being folded out and it's rolling out. So these are all going at 30 degrees. We've got 2 and 12 here. I'm just trying to imagine where it's going to be once they project up. There we go. Now, if I wanted to find 2 and 12, it's very simple. Project up is going to be at 60 degrees. So there's 12, there's 2, 3 and 11. Next one is 4 and 10. So I only need to go as far as the 10 and just bring it straight back. So here's my 10. Try and always keep it neat and tidy. 9 and 5. 8 and 6, we got 7. So, locate our points. Exactly. So there was 1, there's my 2, 3, there's my 4, 6, 7, and so on. Now do the exact same for the opposite side. There we go. Complete surface development, fully done. Question complete.